Good morning, class. Hope you're doing well. So this is the video for worksheet 4.2. The first task on your worksheet is you're going to be using your graphing calculator to figure out what happens when we add or subtract values from the parent function, because the parent function we are using is y is equal to 2 to the power x. Now before we go into anything on this parent function, I hope you can see that as x gets to a negative value, a negative big value, so think of x as say negative 10,000, then y is going to be 2 to the power negative 10,000, and that will be something that's very close to 0, right? So as x tends to a big negative value, y goes to 0. Y goes to 0. That tells me that the horizontal asymptote of this equation, is going to be y is equal to 0. That's the horizontal asymptote. And that line is the x-axis. If I was to sketch the graph of y is equal to 2 to the power x, 2 to the power x, I know the y-intercept is 1 because the a value is 1, so the y-intercept is 1. When x is 1, y is 2, because if I plug in 1 here, I get 2. When x is 2, y is 4. And when x is 3, y is 8. So if I sketch that curve, it's going to look like this. That's the graph of y is equal to 2 to the power x. Now in this activity, you're trying to figure out what happens when the values of d, these values of d are different. Because in the parent graph, the value of d is 0. But you're trying to check what happens when those values are different. So in this first one, 2 to the power x minus 3, what's going to happen is that graph will be shifted 3 units downwards, but it's shifted 3 units from the y-intercept. So the new graph will be, its y-intercept will be 3 units at this point, which is 1, 2, 3. So the new y-intercept, different color, the new y-intercept for 2 to the power x minus 3 will be here. Since the y-intercept is shifted 3 units down, the horizontal asymptote is also shifted 3 units down. So your new horizontal asymptote is y equals negative 3. So your new graph will have a shape like that. Oops. Have a shape like that, looking just like the first one, but just shifted 3 units down. The next one is 2 to the power x plus 4. That's going to be shifted 4 units up. So if this is your y-intercept, the new y-intercept will be 4 units above this one, which is 1, 2, 3, 4. And your new horizontal asymptote will be 4 units above this old one, which is 1, 2, 3, 4. This is your new horizontal asymptote. So your new graph will have the same shape with just 4 units upwards. So in your own words, you can write what this plus or minus d does to the graph of the function. This is our last example, hopefully. So we're still examining. We know that the plus 3 moves the graph 3 units up. But what happens? What does the negative 1 on the x do? Or if it was positive, what does that do? What that does is it simply moves the graph to the left or to the right. Let me try to show you here. So the initial graph, if it was just 2 to the power x, its shape would be something like that. It would cut the y-intercept at 1, the y-axis at 1, and then it would keep going like that. But the new graph, if the x had a negative 1 next to it, if it was just 2x minus 1, instead of cutting the y-axis at this point 1, it will instead cut the line x equals 1, because it's going to be moved 1 unit over. It will cut this line x equals 1 at this point. So that new graph is going to be cutting through that point. So because it's moved 1 unit to the right. The negative means it's moved 1 unit to the right. If it was positive, it would have been 1 unit to the left. So this is what it looks like if it's just 2 to the x minus 1 The positive 3 means this whole thing is moved 3 units up. So that's 1, 2, 3. That's my new point. And my new horizontal asymptote is this point over here. So my graph, I'm going to draw it in red, is boom, like that. What about this one? Example B. So 1 out of 3 to the power x is the same thing as 3 to the negative 1 to the power x, which is the same thing as 3 to the negative x. So it's basically asking us what happens when the power of x is negative. When the power of x is negative, it's going to be reflected over the y-axis. It's going to be reflected over the y-axis. So if it was just 3 to the power x, if it was just 3 to the power x, it would have looked like this, with an intercept of 1 and then going up that way. But since it is technically 3 to the negative x, it's going to be reflected over the y-axis, so it's going to look like this. And you will verify this using your graphing calculator. So flip this f of x over the x-axis. I'm flipping this blue graph over the x-axis. When I flip it, it's going to look like that. Yeah. Okay, I hope that helps. So summary, the value c shifts the graph horizontally either to the left or to the right, depending on the sign of c. D shifts the graph vertically, up or down, the same number of units. If a is greater than 1, the graph is stretched, and if a is less than 1, the graph is compressed. I mean, if a is between 0 and 1, the graph is compressed. If a is less than 0, the graph is reflected over the x-axis. And if the exponential is negative, the graph is reflected over the y-axis. So yeah, this is your homework.